Alright, we're going to start with day 5, which is solving. So we're going to be solving exponential and logarithmic equations. So to solve exponential equations, remember to solve you always take the inverse to get that x by itself. So opposite of inverse is log inverse. When I say opposite, it's inverse. And you can use dash to solve logarithmic. So the inverse of logarithmic is exponential. To solve logarithmic functions. So one way to solve is if the two powers with the same base are equal, and then their exponents must be equal. Okay, I'll just explain this. I'm writing this down, but I'll go ahead and explain it. All it means is if the base is the same, the exponents have to be the same. And this is pretty obvious. I don't think I have to explain more than that. Alright, so now we're actually going to get into solving. So I'll try to do a few of different kinds. So the first thing we're going to try to see is, for me, these are all exponential equations. So in exponential equations, for me to solve, where it has the left hand side and the right hand side, if I can make the base to be the same, it will make it easy for me. For example, 10 and 100 can be represented both as a base 10. So this stays as is, and this will be represented as 10 square 4x minus 5, and remember, power to power you multiply, so this stays the same, and this can be written as 10 to the power of 2 times 4x is 8x minus 2 times, you're multiplying, right? You're multiplying 2 with that, minus 10. Now you can equate the two, because if the base is the same, they are equal, so 8x minus 10. Go ahead and solve for x, and you should get x to be equal to 1. So basically you can move the x over 8s to, this becomes negative 7x, and this becomes negative 7, therefore x equals to 1. Alright, now my question to you is, can I represent 4 and 8 as the same base? Thing is, sometimes you'll have to convert both the sides to the same base. In this case I converted only this side, but in this case I'll have to convert both, because 8 cannot be represented as 4 square or anything of that sort, right? So, but what I can do is I can represent 4 as 2 square and 8 as 2 cubed. So this can be represented as 2 squared to the power of 3x, and 8 can be represented as 2 cubed to the power of x plus 1. Now power to power you multiply, so 2 times 3 is 6x. And this is going to be 3 multiplied by x plus 1 is 3x plus 3. Solve for this, and you should get in this also x equals 1. It just happens to be that. So this is the same thing. They are both, this can be written as 3 cubed, and this can be written as 3 to the 4th power. And I'll let you guys look at the key and figure this out. Should not be too difficult. My next method, when the bases are not the same. When the bases are not the same, you can solve by taking the log on both sides. Instead of taking log on both sides, I can also kind of write the inverse that I've been talking about. So it says solve, and all these are exponential equations which do not have, I'm sorry, here, let me move this up. These are all exponential equations which cannot be written as the same base on both sides. So what I can do is I can convert this to log. So remember, going from exponents to log, we talked about it the first day when I was talking about log. You write it as a log with the same base. The base is 2. This becomes the input, and x becomes my output. Now how do you solve for this? How do you solve for this? I can use my calculator to solve this, but the calculator does not have a log base 2, so x is basically nothing but, rewrite this with a base log 10, because that's what my calculator has, log base 7. Remember, you just ignore the base and just write log 7, and the denominator will be log of 2. Put this in your calculator, and it is approximately, you should get 2.807. You're just putting this in your calculator. You're just putting this in your calculator, and you should get approximately 2.807. I'm going to try to do something a little different. Let's do C. You should be able to look at the key and figure this out. Pretty similar. You're going to rewrite this as a log. But let's look at this, where the exponent, but the exponent is not by itself in the sense that it's got other elements. So 10, 2x minus 3, because you want to isolate the x, you isolate this term, and negative 4 on both sides, so this becomes 17. Now I can rewrite this as a log. So log base is 10, so I don't write anything, and this becomes my input for the log, and 2x minus 3 becomes the output. Now what do? You basically have to get x by itself. So I just write the 2x on this side, and 3 goes to this side, so it's log of 17 plus 3. Therefore x equals log of 17 plus 3 over 2. I can put this in my calculator. I don't need to, the base for this is 10, so I can use whatever's on the calculator, and you should approximately get 2.115. Alright, so you should get what's on the key. I'm just going to do the first step for this because this has a base E. Concept is the same, but let's just go ahead and do the first couple of steps, and the rest of it you can follow with the key. So I will rewrite this as a ln because the base is E. This becomes my input. 2x becomes my output. Therefore, x equals ln of 9 over 2. Put this in the calculator, and you should get approximately 1.099. And this is going to be very similar to this. Again, let me go ahead and do the first few steps. So first, 5e 4x minus 1 equals 10 because you subtract 2 from both sides. And then the term that contains x is still not isolated. There is a 5 here. So e 4x minus 1 equals, divide by 5 on both sides, so you get a 2. And now you should be able to rewrite this. ln of 2 equals 4x minus 1. You should be able to isolate the x and get it by itself. Okay, moving right along. I'm going to move to the next page. Again, there are a lot of problems. A lot of it, if I can show you a few, you should be able to look at the key that's posted and look at the others. Keep in mind, you're trying to solve log functions. Whenever you're solving a log function, always check. Why? Because there cannot be a negative input for log. Always check your answer. Alright. So having said that, this is really straightforward. A is really straightforward because they both have the same base on both sides. So you can straight away write it as, if the 5x minus 1 equals x plus 7. Because the base of the log is the same. And then you can solve for this, and you should get 4x equals 8. X equals 2. Let's do a check. Check will be log base 3 of 5 times 2 is 10. Log base 3 of 9 should be log base 3 of 9. It's correct. So you want to make sure you're doing the check for all of them. This one does not have log on both sides, but this input can become an output if I rewrite this in the form of an exponent. So what will I write my base as? 5 square equals, and this becomes my output, right? This becomes my output, so 3x plus 1, and this should not be difficult for you to solve. You should get, this becomes 25, 3x plus 1, go ahead and solve this, and you should get x equals to 8 when you try to get x by itself. And then substitute the x, and it's log base 5 of 3 times 8 is 24, 25 equals 2. As long as the input for log is not negative, you are good to go. Okay, so this is similar to, you should be able to do that, equate these two. This one is similar to that. So basically you'll rewrite this, e to the 0 equals 3x plus 1, right? This is my input for the base e, and this is my output. What is e to the power of 0? E to the power, anything to the power of 0 is 1. Go ahead and solve for x. X equals to 0. Check. ln of 1 equals 0. That is correct. Because e to the power of 0 is 1, so it is correct. Alright, let's look at something a little different. I'm skipping a few because some of them are kind of similar. You should be able to follow it with the key. If you're not, you can always ask me. So let's look at this problem. So here, what I notice I do see log base 2 on both sides, but having said that, I need to have only one log base here. I can't equate them without it being two different elements. So, but I can do condensing. Remember, we've learned that I can do condensing. I'm sorry, you're not able to see this. I keep doing that. So I'm working on F, sorry. So basically, this one is going to be, first step is log base 2 x to the power of 4. You guys remember this, right? Using the log property, plus log base 2 of 5 equals log base 2 of 405. Now I can still combine this. Log base 2, because it's addition, I can multiply 5 and x to the 4th power equals log base 2 of 405. Now they both have the same base. That means I can equate the input. 5x4 equals 405. Go ahead and solve this. You should get x4 equals 81. That means 4th root of 81 is 3. 3 to the 4th power is 81. But it's going to be plus or minus 3. Check. X equals plus or minus 3. You cannot have a negative value. X equals just positive 3. And does that work? That works, because the only x that is there is here 4 log base of 2 of just 3 works. So that is okay. Whereas if I took a negative 3 does not work. Yeah, because we know the input for the log cannot be negative. Okay. Let's do, I want to see, why don't I pause here, and I'd like you guys to see if you guys can work on these two by yourself. But I'll pick it up at the next video. I'll post another video for the same lesson for day 5, and we'll pick it up right here.